Thank you very much. Well, it's a good pleasure to be here today. And usually people say that the best way of learning something is to use it. So even though you're watching a lot of talks, for you to see that, oh, I really understand, I can use this for something real, the best thing is to put your hands on the code and try to make it work, okay? So this session is at least an attempt of giving you this kind of opportunity. So basically what I'm going to do, I will start making a small introduction for the CST cognitive architecture, or the CST toolkit, and what are the main principles behind it, okay? After that, I will move to a code, to a demo code that I have already prepared for you, and that you already received the link to download. For the practical aspects, you might need to make installation of some software in your machine. So most of you received an email advising that you need to do that installation. I'm not sure if everyone did this installation. If you didn't, maybe you can take this first part of the introduction for starting these installations, because sometimes you have to download some code and it takes some time. So you can spend do this in this first start of the tutorial, okay? If any one of you don't have the link, probably you tell me and I'll try to make it available, for example, there, or I can just print it here. It's okay. Okay, so if you didn't have access to it, cst.fee.unicamp.br/RAAI 2019, okay? And in this link, I have the other links for all the software that you need to download, okay? I will be using here the NetBeans software for you to see your programs. If you already know other IDEs like IntelliJ or Eclipse or whatever you are used to use, there's no problem. Okay, you can use it if you wish. I am recommending NetBeans because NetBeans is quite easy to use, and I usually have this practice with my students for teaching them how to program in Java. Okay. Well, basically, as I said, the main goal is to provide a hands-on experience on how to use the CST Cognitive Systems Toolkit. Probably, if you don't need Java, you will not benefit too much, because you might actually need to understand Java code in order to be able to generate your own code to conclude the tutorial. But nevertheless, if you want to risk, you can at least stay for the first part when I'm making this introduction, and you can have an idea, a feeling, and maybe later you can try to complete the tutorial at home. I intend to leave that link available forever. So if you want to come back, or if you want to refer your friends to, oh, it's a nice toolkit for me, and then you can use this link as a reference for them to try to run the tutorial, okay? Basically, you need the Java SDK 1.8, and this 8 is quite important, because if you have newer versions of Java, our virtual environment is not going to work. It needs Java 8 specifically, okay? There are two options for the Java code. You can download the Java code from Oracle if you wish. But Oracle has recently changed the license of the code, so it's free for your personal use, but you cannot use it in a commercial application. So if you have a notebook that belongs to a company or something, maybe you prefer to use an alternative solution, which is OpenJDK. I have provided both links in that link over there, and you can choose among the two. Hopefully, the two of them is going to work. And the second, we will need NetBeans. Okay, there are also two versions of NetBeans available. There is NetBeans 11, which is now hosted by Apache Foundation. And there is the old NetBeans, the NetBeans 8.2. That is, the difference between them, they do not differ too much between each other. They have, the main difference between them is that NetBeans 11 works with different versions of Java, Java 9, 10, 11, 12, okay? And NetBeans 8.2 works only with Java 8. But because we are staying here with Java 8, you can use either NetBeans 8.2 or NetBeans 8.11, okay? I just discovered yesterday that if you have a MacBook, there is a bug in the NetBeans 11 code that will give you a little bit of difficulties. But nevertheless, you can use NetBeans 11 without problem. I will be using here NetBeans 8.2 just to not incur in the bug. So if you have Windows, probably it's not going to affect you, so you can use it anyway. If you have Linux, it's better because it works perfectly in Linux. Okay. At home, I only use Linux, and because I have to use this MacBook, I just discovered that there is a bug in the MacBook version of NetBeans 11. Okay. So this is the basic software that you need to install. After that, I will show you our software. You also need it, but it's quite fast. It's from GitHub, so you can download it and use it quite fast. Okay. So these are the requirements. Okay. And then I will try to start with you with some of basic ideas of the CST architecture. Okay. Probably you attended my talk today in the morning when I made a bare introduction to cognitive architecture. So the idea of a cognitive architecture is to have a software implementation of the model of what is happening in the mind. Okay, so there are what we call cognitive models, and we translate these models into software. Okay, and in order for do that, using CST, we have some core ideas that are the most important ideas for you to understand. If you can understand that, most probably you'll be able to start programming the environment. Okay, so basically we have two different entities, software entities, that are important for us. The first one is the idea of a memory object, or a memory, or a sign, if you wish. Okay? So a memory object embeds some piece of information. Okay? That could be whatever. In our case, a memory object can be any Java object. Okay? So it can be a class, it can be a graph, it can be a list, it can be any data structure that you wish that is important for you to represent your data. Okay? Usually it has some aggregated information, so the memory object is not exactly a pure Java object, but it is just like a wrapper for the Java object. So you can imagine just like if you have, this is the memory object, and here inside we have the Java object. Okay? But we have also this wrapper around the Java object that embeds some information that is important for us for the architecture to work. Okay? And basically, the most important things for us to understand is that I have a name, for each of these memory objects. I can attach a string name for each of these Java objects. I have an evaluation, which is a double point a floating point in double precision that measures some utility value that we are going to see how it works during the demonstration. So imagine that it's a real number that is attached to the object, and you are going to make use of it in some situations. And you have the I here, and the I is the information. And the I is the Java code. So the I is the Java object that can be any Java class that you have available in the Java language. Okay? So the memory object is our standard container of information. Okay? And the idea is that everything that is important, in some sense, is represented as a memory object. But the memory object does nothing. It doesn't make anything. All the behavior is concentrated in these other things here that we call codelets. So the codelets are the building blocks of a CST application. Or in other words, the codelet are the building blocks of my cognitive architecture. The idea is that we are going to assemble a connection between codelets and memory objects, and this is going to be our architecture. Okay, that's the basic idea. Well, the codelet, the idea of codelet is not mine. It is an idea that was created by Douglas Hofstadter in his cognitive architecture called Copycat. It was from the 85 or 86. Maybe most of you were not born by this time. The idea of a codelet is the idea of a process that runs very fast, okay, and that is being repeatedly being called, okay? So in terms of implementation, you can imagine that when you start a codelet, you start a timer, and this timer starts to make ticks to the codelet, okay? And for each tick that the codelet receives, it makes a small processing. Very small, very brief, and repeatedly, okay? So this is the basic idea of a codelet. And I'm going to show you later the overall software architecture of the codelet. But that's the main idea, okay? So this proc here is the name of the method of a codelet that is called in each of these timer events that happen in the system, okay? The system might have different codelets, and in principle, they all run with the same time base, okay? If you start the system without any configuration, each of these codelets will be called by 300 milliseconds, okay? But you can change that. So we can tune, and for example, some codelets that require more time, because otherwise they are going to be fooled with timer events and they will just not work. You can change this time basis, so you can reprogram for each codelet from which periodicity it's going to be called. So if it needs 1 second, you program it for being called 1 second. There is also the possibility of profiling. What is profiling? Profiling is a way in which I start, okay, I don't know if it's enough or not. And then I put something to measure. And after this measurement, I just realized that, oh, it's not going to work with 300 milliseconds because it is taking 700 milliseconds for operating, okay? Then with this information from the profile, you can change that for, let's say, 800 milliseconds, and then it will be able to make the processment that is required, okay? Well, the codelet has two different input ports, okay? and one output port and one activation value. Okay, let's try to understand how this works. The first one is the local input. The local input is the standard input, is the way in which generally every codelet receives information from a memory object. Okay? So, for example, this codelet here is receiving this information from this memory object in its local input, okay? And its output part is going to another memory object, okay? So this means that it receives information from here and generates information from here, okay? That's the main idea. But with CST, we are interested in implementing an idea that is the idea of machine consciousness. I'm not sure if you have already learned or listened about machine consciousness. Machine consciousness is a field of research. There's a lot of people working in machine consciousness, not too many, but at least some people. There are some cognitive architectures, just like LIDA, which uses machine consciousness. And machine consciousness requires us, at least one of the possible approaches to machine consciousness, requires us what we call a global workspace. A global workspace is it's just like a blackboard. Okay? So instead of coming and giving my information directly to him, I put the information here on the blackboard. So the blackboard works like a global workspace. And what happens is that this global input here is the input that receives whatever is written in the global workspace. Okay? In some particular situations where you want to use the codelet to build a machine consciousness module, then you use the global input. Okay? If you are not concerned with machine consciousness and you are not going to use a global workspace, then you don't need to pay attention to the global input. Okay? But it's here because the idea is that this codelet is a foundational piece of software that is going to be used in many different kinds of cognitive architectures. So we provided it here because in the particular case that I need that consciousness codelet for dealing with a global workspace, I will need this global input. And for the same reason, I have this activity level output here. Okay, so there are some possible situations in which we will have many codelets that are competing to each other. And the way for us to determine who is going to win the competition is through this activity level in the exit of the codelet. Okay? So the activity level and the global input, they are important only if you are going to use it for machine consciousness. Okay? If you are not concerned with machine consciousness, you need to deal only with the local input and the output. Okay? Good. If you have any question, please interrupt me, okay? Because, or if you prefer, after I finish, you can call me. I can give you a more elaborate explanation, okay? Well, please. No, they are completely out of order. It's a multi-thread system. Each codelet is running in its own thread, and so you can imagine that things are completely chaotic. Okay? If you need to have something following some prescribed order, then you need to create conditions for that. For example, putting slots here in your class that has a timestamp or something, and then you can use this timestamp for create a feeling of order. But in principle, each of these codelets is just like an independent agent doing something very particular and being called from time to time in a non-specific order. and the Java thread system that is going to make these calls. Okay? Perfect? Yes, that's the idea. In the next tick, yeah. Okay? So, what happens is that each codelet can be a neuron, for example, in a neural network. Okay? This could be a possible implementation for a neural network if you wish. Okay? Or we can have a codelet as a full neural network in its side. Okay? It's up to us what we can do. And an important thing here is that these codelets, with their outputs and inputs, they can form what we call coalitions. So this means that, okay, these three codelets, in some sense, they cooperate to each other in order for a possible behavior to outcome. Okay? In this case, for example, we can imagine that this first codelet here that doesn't have any input object, okay? It is collecting something from the real world. Okay? It can be, for example, receiving information from a network socket, or it could be sensing with a sensor in the environment, or you can imagine anything happening here, giving it information, and then it processes that information and stores that in this memory object. Okay? Then on the next step, this memory object is going to feed this codelet that is going to generate this, and that is going to be taken by this. And because this one doesn't have any other memory object, possibly it is doing some action. Okay? It can be writing in your screen, it can be doing whatever, it can be sending commands in a network socket to another program, for example. Okay, so many things are possible here. And we can see that these three, they form a coalition. Okay? An interesting thing about coalitions is that, well, we can have static coalitions like this one. Okay? So in this case, a priori, I know that this is going to feed this, and this, and this. Okay? But because we have this global input, we never know who is posting things on the global input. Okay? And so what is possible in this architecture is that receiving some information from the global input, I discover other codelet here to whom I can collaborate, and then I can send something to a memory object, and then we can change dynamically this coalition in time. Okay? So we can do very interesting things with these very simple ideas. Okay? So basically, this is the most basic ideas that everyone needs to understand. We have codelets, we have memory objects, and they will work together. I cannot, for example, exit from one codelet to another code directly. So every communication from one codelet to the other needs to pass through a memory object. That it was one of the main principles of the architecture. Okay? But you can see that with this very simple core, we can build everything. We can build multi-agent systems, we can build distributed systems, we can do a lot of things. Okay? And basically, for you to integrate any piece of software that you already have to CST, the only thing that you need to do is to follow these small conventions. Everything that does something is a codelet, everything that stores something is a memory object. Okay? That's the main ideas behind it. Okay? Well, then we go cognitive, because right now we are just having a computational structure for us to work. Okay? And now we are going cognitive. You can see from the back slide that all the codelets, they are stored in what we call a code rack. And all the memory objects, they are stored in what we call a raw memory, okay? So this is emphasized in the architecture. But now, what happens? This is the code rack, and this is the raw memory. But now we are making some attachments of these codelets to cognitive functions, okay? So I might have, for example, sensory codelets that are responsible for getting information from the environment, okay? These sensory codelets possibly will put memory objects in a sensory memory, okay? Then we are going to have some perceptual codelets that possibly will get memory objects from the sensory memory, and they will write on a perceptual memory, okay? And then we can have, for example, we don't need to have all these codelets, okay? They are just what we call a reference architecture, okay? Just for us to think about. For example, we can have things very simple like sensory codelets, procedural memory, motor codelets, and that's it. Very simple agents can be constructed like that. But we can have other things that will enhance these things. For example, we can have what we call attention codelets. Why attention codelets? Because, well, there's a lot of information going on here on the perceptual memory. Probably I don't need all the information. What the attention codelets are doing, they are filtering out from all the manifold of information that I have, those that are important to me in some sense. And this is very used in many cognitive architectures to have attention codelets to just detect things that are happening at the environment. I don't need to pay attention, for example, right now, you are listening to me, okay? But if I drive your attention, you could see a sound in the background, probably from the projector, okay? When you are listening to me, you don't pay attention to the sound of the projector. Why? Because you have attention codelets that are driving your attention to me, okay? And leaving out the information that is not important, okay? That's basically the requirement for attention codelets, okay? I will go to this side here. We have what we call behavioral codelets, which are responsible for the behavior in the system. Today, in the morning, I talked a little bit about the different kinds of behaviors that we can have implemented. These behaviors will be responsible for, these behavioral codelets, they will be responsible for implementing these behaviors in the system. Here in the procedural memory, they will create motor actions that will be used here by the motor codelets to generate something. Okay? This could be a very simple cognitive architecture, for example, implemented with rules. Okay? But it doesn't need to be rules. I can have, for example, here in the procedural memory, a neural network. Okay? And I can have some information that is encoded here in the perceptual memory as signals collected from the sensory memory and treated. And then I can use these signals together with the neural network here in the procedural memory to generate a motor action and then act at the environment. Okay? So there are many possible uses for the CST toolkit to build cognitive systems. Okay? But then things start to become interesting because we don't need to be simple. We can start to become a little bit more complicated because, you know, usually in our memory, we don't have only perceptual memory, procedural memory, motor memory, and sensory memory. We can remember, for example, of things that happened at the environment. And this is what is stored here in the episodic memory. The episodic memory stores what we call episodes. So if you exercise your episodic memory right now, I can ask you, for example, where did you have lunch today? And instantaneously, you are going to remember, oh, I didn't have lunch. Or probably, oh, I was in the cafeteria and I just arrived here. And so this information is here encoded on the episodic memory. Or maybe I can ask you a question. For example, you have some knowledge, just like Moscow is the capital of Russia. Okay? This kind of information is stored here in the semantic memory. Okay? So information that is not temporally connected to the world are here. And those that you have time, then they are here in the episodic memory. Okay? But anyway, these two are what we call long-term memory. They are memory for facts, they are memory for episodes. But what about that memory that we use to think? If I ask you, for example, to make a plan for going outside and picking up something that is in the car, what are you going to do? You are going to use a different kind of memory that we call working memory. The working memory is what people call, there is in the tradition of the study of cognitive system, there is a story or a tale about the magic number 5. So people usually think that, 5 is the number of things that you can put together in your working memory in order for you to think. Okay? Oh, 7, sorry, not 5. my mistake. So you're using your semantic memory for that, so it's good. So it's a magic number 7. So 7 is the maximum number of things that we can have in the working memory. There are some tricks, because you can embed them in bundles, and then a bundle counts as 1. Okay, so it's not exactly 7. But anyway, the idea is that this working memory is a memory that is not too big. It is a small memory. Okay, and this memory usually fades out very quickly. Okay, so if, for example, I give you my phone number, if someone still does that, but if I give you my phone number, probably some seconds after I say it to you, it will be vanished. You're not going to remember it anymore, unless you take a notice of it. Okay? So differently from the semantic memory and the episodic memory, which are large, long-term memories, the working memory fades up very fast. And the idea is to store information for a small amount of time just for some computation to happen. Okay? There is some people working in how working memory works in the human being. And they have a theory that is developed by a guy that is called Baddeley. I don't remember his first name. It's just Baddeley. That there are 3 different kinds of sub-memories in the working memory. Okay? The first one is what Baddeley calls the phonologic loop. And the phonologic loop is exactly this piece of memory that I told you. Okay? It is the memory where you store, for example, language. I am talking to you right now. Okay? You are receiving my words, and these words are being stored here on the phonologic loop. Okay? So if I say the number of my phone to you, this is where it's going to happen. So it's a sequential set of pieces of information that are stored in a serial way. Okay? This stays here on the phonologic loop. The second one is what Baddeley calls the visual sketchpad. The visual sketchpad is used for you to have, from your position, a kind of distribution of objects around you. Okay? So, for example, in my visual sketchpad right now, I can see a lot of people sitting down here on the chairs. Okay? I can see the camera over there. I can see the door. I can see the lights. So this spatial distribution of things around myself they are stored here in the Visual Sketchpad. Okay? And Bedley also calls about a third kind of submemory in the working memory, which is the episodic buffer. The episodic buffer is different from the episodic memory. It's important for us to understand. The episodic memory is a long-term memory. It's where I store the long episodes I have passed in the past. Okay? But the episodic buffer is very important. Why? Because it's here in the episodic buffer that I create my sense of present, of something that is happening just here right now. Okay? So it is a kind of a building of an episode based on the sensed information from the environment. Okay? So now you are in front of your computers, reading your emails and watching to me, and you are right now collecting this information, summing everything, and creating this episode. No, now I am at the hall attending a tutorial on cognitive architectures. Okay? And this mounting of the episodes is done here in the episodic buffer. Later, these episodes will be stored in the episodic memory, okay? But the mounting of the episode, and this is still an open question, how we do that. There is no consensus on that. People are still investigating how the episodes are mounted here in the episodic buffer. But after they are mounted here, they can be stored for long term in the episodic memory. Okay? Good. And what about this yellow star passing through all the memories? This is the consciousness. And this is what the machine consciousness do. Machine consciousness basically is a great filter. Okay? So you can imagine that this is all your memory. Okay? This is all your memory. But not all this memory is available all the times. Okay? Sometimes it is there, you need some effort to bring it back. Okay? But there is a kind of a competition between everything that is in your memory. They are competing to each other. Okay? And for some reason, and there are cues that drives consciousness that are in some sense based on attention. Okay? And some of these memories could be any kind of memory. They will be propagated to your consciousness. Okay? So the big star here means that everything, any kind of memory could go to the global workspace and go to consciousness. Okay? And it is going to be the role of the consciousness codelet to do that. Okay? The consciousness code do exactly that. It just decides which part of the memory that is going to consciousness. Okay? Good. Well, so we might have also imagination and planning codelets that are making plans, that are making imaginary things. Okay? We can have emotional codelets for providing emotional support, just like I explained it today in the morning. We might have learning codelets exactly running on the learning of other kinds of knowledge, okay? And in some sense, this is the reference cognitive architecture. So I don't need to use all these codelets. I can use a part of them, a composite of that, okay? I don't need to use all the memories. I can use only part of them. But the idea is that if I want, I have a reference for how I organize my codelets and my memory objects such that I can arrange a cognitive architecture. Okay? Could you have at least a small understanding of this? It's just a reference. Okay? It doesn't need to be like that. Good. Well, so let's go a little bit to software. Okay? These are classes, these are Java classes that we have available in our CST toolkit, okay? These are the most important for you right now. There are many others, of course, that we are not going to go deep into them today, okay? Today it's just a small bootstrap for you to understand. Don't be frustrated at the end of the tutorial. You're not going to work with consciousness today, but if you wish, you can contact me, we can talk. Today what we have a class that is called mind, okay? So every cognitive architecture created by CST will be derived from the mind class. You see in our example that we are going to create a class agent mind which inherits from the mind class, okay? And the mind, in this particular case, is collected by two different objects, the code rack and the raw memory. Any surprise for you? No, this was exactly what I showed in the other diagram. This is only a software implementation of it, okay? Well, the code rack will have a collection of all the codelets that you are going to create. And your codelets are going to extend the codelet class. So you are going to create your own codelets, and you can name it the way you want, okay? And here, in the raw memory, we have a small complication here, and I hope you can understand what is going on. In the other picture, I told you about the memory object, okay? But we have a situation that we are going to see today where just a memory object is not enough. And I will explain that later to you. But right now, what happens is that I have two kinds of memory objects. The first one, that is the memory object in itself. So there is a class called memory object, and you are going to have your own memory objects which are using this, okay? But I also can have what we call a memory container. And the memory container, I will ask you to keep your curiosity for some time. I will come back at the end to the memory container, okay? Because I need to explain some things before talking about the memory container, okay? It's not too difficult, huh? It's quite simple, okay? These are the main principles that we have for creating something with the CST, okay? We have my codelets, I have memory objects, I have memory containers, and I have the interface memory, which can be either a memory object or a memory container. These things are in the raw memory, these things are in the code rack, and the code rack and the raw memory compose the mind, okay? In more sophisticated minds, in more sophisticated cognitive architectures, we can have other things here, okay? All those memories that I have presented to you in that diagram, I could have, for example, an episodic memory. I can have, for example, a semantic memory. What those things are be doing? Well, every memory objects are in raw memory. But these other memories here, they could be selections of specific pieces of other memory objects which are in the raw memory. So you can imagine just like pointers, okay? They are pointing to memories which are here, okay? But let's stay with this for some time. Yeah. Yes. In principle, any kind of technique can be incorporated in here. What you need to do is you need to create a codelet that incorporates something. For example, imagine that you have an implementation for the A* method, okay? Then what you need to do, you need to create a codelet that calls your procedure and follows these rules, and that's it. It's incorporated, okay? In our case, we have a binding to the SOAR cognitive architecture, because SOAR is a quite nice planning system. And because we didn't want to have time or burden to create a planning system, we just created a binding of SOAR. We created a SOAR codelet, and then using SOAR codelet, I call SOAR and continue with the rest of the architecture. if I want to integrate deep learning, for example, okay, I can use deep learning for J. I create a codelet that calls the network, and that's it. So I can integrate everything, okay? The only requirement is you need a Java binding, okay? But this is not so difficult, okay? Good. So now I will introduce you to the architecture that we are going to use in this tutorial, okay? The colors are not so good, but you can see that this is a virtual environment. It's a 3D, 2D and a half, let's say. It's not real 3D, but you have here a small robot, okay? It is a robot where you can control it, you can move it, you can have a lot of actions that you can, not too many, but that you can give for the robot, okay? And at the environment, you can have apples, nuts, and gyros, okay? The gyros can be of different colors. There are, I believe, 6 different colors for gyros, okay? The robot is looking to a direction, and you can see the vision of the robot available in one of these 2 panels here, okay? If we have more than 2 robots, it's possible to have as many robots as we want in the environment. But we can only see 2 of them at the same time. And we can change, we can put this robot here, and then we can change. This is just for us. This is not what the real robot is seeing, okay? That's basically the idea, okay? Well, what this robot can do, okay? First, this robot spends energy in its traveling, okay? And it is able to refill this energy by getting food, apples or nuts. What are the difference of apples and nuts? The difference is that apples, they deteriorate with time, okay? So they appear, and after some time they became rotten. And if they are rotten, they cannot be consumed anymore, okay? Nuts, on the contrary, they are always good. So if you see a nut, you know that you can pick the nut and you can stay with the nut as much as you can, and then you can eat the nut, okay? But why? Because we can think about, for example, 2 creatures competing to each other. And the interesting thing is that one of the things that this creature is able to do is to bury the nuts or the apples down in the environment, okay? So if you are close enough to an apple, for example, you can bury the apple in the ground, and then you can return later and unbury it, and then you can get the apple, okay? You can do the same with the nut. But the problem is that if you bury the apple, you need to consume it in a given amount of time. Because if you unbury it, for example, after it becomes deteriorated, then you're not going to be able to consume the apple anymore. But the nut you can bury, and you can unbury it, it's always be good, okay? So if you are competing between 2 agents, then you have the chance, for example, for, oh, I see a nut. I don't need it right now, so I bury it. And if the other agent don't know where I am, he will not be able to come and unbury the nut, okay? So things are simple, but not so simple. There are some small complications on it, okay? The same happens with the Jews, okay? The idea is that the creatures need to pick the Jews, and they can exchange these Jews to points. But there is a table. There is a table that shows to me what are the combinations that I can do with Jews to exchange for points, okay? So this is one of the screens that I can have with the application. And so what we have is that after I start the environment, I can create a leaflet. Okay, a leaflet is just a table. Okay, for example, this leaflet, this one is not filled, but for example, I can say 2 red and 1 yellow is going to give me 15 points. 2 reds and 1 white can give me 25 points. Okay, so usually we have combinations of 3 jewels from different colors that are going to give me different number of points. And so I need to be smart enough to pick the jewels such that I can get the best number of points. So the goal of the game is after some time to have the better score. Okay? So if I have already the leaflet, I can go to a trading point, and then if you go into this trading point, then you can exchange your jewels for points. Okay? So this is basically the game. There are other things. They have a value of serotonin and endorphin, but this is not relevant for us right now. My students, they use this, for example, for trying to create some emotional mechanism and things like that, but we are not going to use it here. Okay? It's here just for you as a curiosity. Okay? And the energy here, it keeps going down. Okay? If you eat an apple or a nut, it increases a little bit. Okay? It's not a good policy to eat every nut and apple that you find, because if you already have almost full of energy, it is going just to feel like this. So you're going to lose the opportunity of using it later. Okay? So basically it's the application, not too much complicated than that. And this is the cognitive architecture that I will give to you as an example on how it works. Okay, let's try to explain. This is very simple, okay? And the idea now is to explain to you this small architecture, okay? Later, I will show you the code that implements it, so you can see how this idea is implemented in the code. You have this code available to you, okay? And then I will make a challenge to you, okay? We are going to make things a little bit complicated than that. And then you have to make some small changes here, using that as a basis for create and solve the challenge. Challenge is not so difficult, okay? So just for you to know, this tutorial is actually a class that I have in my course on cognitive architecture. So in my course in my university, we study during the year 4 different cognitive architectures. We study SOAR, Clarion, LIDA, and CST. Okay? And what you're doing here today is one class that usually they spend 4 hours for doing that. We have 3 hours, a little bit, not exactly 3 hours, but probably if you cannot finish the challenge here, you can finish later. Okay, there's no pressure, but some of you probably will be able to finish today. Okay, well, let's see how it works. You can see that we don't have here all the codelets and all the memories that I have shown you in the other slide. We have a smaller amount of them. Okay, we have only sensory memory, perceptual memory, and motor memory. So, quite simple. This architecture here is an example of what we call a subsumption architecture. I think it was, I don't remember, one of the presenters today in the morning, he talked about Brooks architecture. This is an implementation of Rodney Brooks' subsumption architecture using CST. Okay? So it's one possible architecture just for you to have a view. Okay? Well, how it works? We have 2 sensors. We have a vision sensor, and we have an inner sense sensor. It's true that in a real situation, things are a little bit more complicated. Okay, so these vision codelets and inner sense codelets, they can be quite complicated. In robotics, for example, there is a field of study that is called SLAM, simultaneous localization and mapping, that do exactly this. They create an inner sense that provides me with a position in the world where I am, okay? And it also maps the objects around me. In robotics, this is a whole field of research. Here we have a very small codelet that is going to give us everything that we need, okay? So we are stealing in some sense, but not so bad, okay? And we also have a vision. So the idea is that the vision is going to give here me a vision MO, a visual memory object, and the inner sense is going to give me an inner sense memory object. This is a Java class. This is a Java class. I'm going to show these classes later, so just remember the whole idea, and then we will go to the code and see these things in the code, okay? Well, this is sensory information. It's just a representation of the environment. Then I need to use this information by two perceptual codelets. What is a perceptual codelet? A perceptual codelet is doing some detection algorithm in order to create a higher level kind of knowledge, okay? In our case, we have two perceptual codelets, the apple detector and the closest apple detector. The apple detector is going to use the vision memory object, and it is going to, around the objects that they have available, which of them are apples, okay? And it is going to select only the apples and put here in this memory object, the known apples memory object, okay? And the known apples memory objects are a list of apples, okay, with the position of each of the apples in the environment. And you know, this seems to be useless, but in fact this is very important. Why? Because if I am here and I am looking to a specific part of the environment and there is an apple here, and if I move like this apple is not anymore in my sensory field, okay? So I need to have some way of storing the other apples that I have seen in the past, such that I can think about that and to choose that I'm going to pick this later, okay? So here I have a list of all the known apples in the system. And here, the closest apple detector uses this list and uses the position of the agent, okay, to detect which is the closest apple. So here we have only one apple here. And this could change, okay? This could change. Well, so after these things work, we have here a list of known apples and the closest apple. And then we have three behavioral codelets, because we have three different behaviors for this creature right now. It can go to the closest apple, so they know the position of the closest apple, they just move to the closest apple, okay? If they are close enough to the memory, to the apple, it can eat the closest apple, okay? And if there is no apple available, it is going to forage. What is forage in this case? The agent will be rotating, okay? It just rotates until, oops, there is an apple here. So it starts foraging, and it goes, for example, to the apple and eats the apple, okay? So in this simple problem, we have three different behaviors, okay? And the go to closest apple and forage, they both actuate in the legs memory object, because you need to move, okay, to turn or to go. And the hands memory object is connected to the eat, okay? And so we have two actuation codelets, the hands actuation codelet, the legs action codelet, that will command the architecture for these things to happen in the virtual environment, okay? So basically, this is the architecture that I'm going to present you. You are going to receive that working, okay? Any doubt here? No. They are always running all the time, okay? What happened is that, for example, the it closest apple, if there is no closest apple, it just don't do anything. If there is a closest apple, it will go to the, if it's possible to eat, it is going to eat, okay? Please. In this case, they don't. This is the next step, okay? But the energy consumption, the information about the energy is here in the inner sense code. So here we have the level of the battery, which is a number between 0 and 1, okay? Basically like that. Any other question here? No? Okay? Can you go? Okay. This is, I will show you later this inside the NetBeans code. So these are the packages, these are the classes in Java that we are using. So we have here the agent mind, the environment, the experiment main. I will show you all of them. Then we have behavioral codelets, motor codelets, perception codelets, sensor codelets, and memories. And we also have here a support class that I'm going to explain later. I do not spend too much time here, okay? So, what we are going to do, okay? I already sent you the link, which is that link over there. I hope that by now you have Java and NetBeans and the source code already downloaded, okay? Before activity 1, I will still show you a little view of the code, okay? But the first activity for you is to take your time with the code, okay? Because even though I'm going to show it here, I know that I will be too much fast for you and maybe too slow sometimes, but you need to have your own time with the code to read it and to understand it. This code is very simple, so you are not going to take too much effort for doing that, okay? So, first, we need to understand the environment, okay? The word server 3D. Then we need to understand the proxy. I will explain what is the proxy. And then we are going to the demo CST. Okay, let's do that here right now. I will run the code for you first, and then I will show you the code later, okay? Okay. So, I already downloaded all the code here. I will first run the word server. You see that, what happened here? Oh, some problem. Demonstration effect. Probably it's related to the, oh, this could be a burden. I'm not sure if it's going to work here in the display. It works here on the computer, but let's try again. let's see if it works. I hope so. No, it's not going to work. That's good. Well, it is not working here because this software requires OpenGL, and probably this display here doesn't work with OpenGL. So sorry for that. I will ask you to try to run that on your machine, and then you can have an idea of it. Huh, this is really something. Yeah, it's not going to work. No problem. We go to the code. Later on, when we finish this initial demonstration, I can go in your machines and try to show you the working of the environment. Okay. It works here in my notebook, but not with the display. Okay. So I will start. I cannot show you right here the word Sarah, but I will tell you about the proxy. Okay. The proxy is a piece of software where we basically have classes to mean the different objects that appear in the scene. Okay. So there are many classes here, but the most important for you to know is this WS3D proxy. Okay. You just need to know how to start it, because you are going to need it in some way. And then after that, we will need this class creature. Okay. And the class creature, what you need here is to know about the different commands that you can use. Okay, so you can use. This is strange. I think that I'm using the wrong code here. Let's get creature. Where are the sets? I think this is a wrong one. I need to download the new one. But what you need here are two classes: the class creature and the class world. Okay, and I will show you why. I will show these on the demo CST. Okay, in the demo CST. If we go to the main class of the demo, is this class here. And you see that it is a very where is it? Oh. Okay. You see that it's a very simple class. Okay. Basically, what we do, we create a class environment. So I do a new environment, and then I have this class agent mind, and the agent mind I do a new agent mind. Okay, and this is all you need to start your application. So let's go to each of them. So the first one is the class environment. In the class environment, what we do? Well, we make some initialization, so we are running in the local host because we are in our machine, okay? Just for you to understand what happens, the application connects to the virtual world using a socket port, okay? So I need to give a local IP and a port for it to work, and it is listening in the port 4011. Okay, this is the port that we communicate with the word server. Okay, we create a creature. This class creature is in the proxy. Okay, I will download a new version of the proxy for you to show. And here is what we do at the beginning. We just create a world, so we get an instance to the world, okay? And the world is the simulation, okay? Just as it is. Then I do a reset in the world to just kill everything, and then I start creating things, okay? I do, for example, I create food in one position, I create food in another position, I create food in another position, and then I create a creature, so I insert a creature in the world, and these are the references for these creatures. If you wish, you can have reference for the food too, but you don't need, so I'm not doing it here. And then what I need to do is to simply start the creature, okay? And once the creature is started, the mind of the creature is going to use this creature, okay? Well, if we go back to the experiment main, we will see that I created the environment and I store the environment in this variable env. And then I pass this environment for the agent mind. Why? Because the agent mind needs to connect with the creature to control it. Okay? But now there comes the interesting part, the agent mind. And you see how simple it is to create a mind using CST. Let's take a look. Well, first of all, what we do, you can see that the agent mind extends the mind class. The mind class is the class from the toolkit, okay? I make some initialization. I basically use a speed of 3. 3 is good for my laptop. For you, it can be small or it can be fast. You need to tune that. It depends on the quality of your processor, the amount of memory that you have. The reach distance is the distance that you need to be close enough to the food to eat it. Okay, so in our case it's 50, okay? It should work. Dots. Pixels. Yes, 50 pixels, yeah. I don't think about that. It's 3. It's a number. Okay, you try and error, and then you keep changing. Okay, it could be 3 pixels per tick, but I'm not completely sure about that. Okay, then I'm going to declare here all the memory objects that I have shown you. Okay, notice that I'm putting here memory. Why? Because memory is a common interface for the memory objects and for the memory containers. Okay, so I have one memory object which is the legs, another one which is the hands, the vision, the inner sense, the closest apple, the known apples memory objects. But you remember that the memory objects are just wrappers. We need an inside object here. Okay, so we need to initialize all these memory objects. Okay. So we start with the initialization here. First, we create a memory object and give this name legs, okay? And here I pass an empty string for it. Why? Because this is going to be a command that I will be sending to the legs or to the hands for it to do something in the world, okay? By this time, because at the beginning it should stop it, I will just send an empty string, which means that it's going to send an empty command and nothing is going to happen, okay? Later, we will see that here we are going to use a JSON string in order to command the creature. But I will show you here in the sequence, okay? Then I create the hands, the same thing. Then I create a list of things, okay? Why? Because I will see that my vision system is going to return to me a list of all the things that are in what they call the frustrum of the creature. The frustrum is just like a triangle, okay, that comes from the actual position of the creature, and everything that is inside this frustrum is included in this list. Okay, this is one of the features of the environment. So I create a list of things and call it vision list. And then I create the vision memory object and I put the vision list here. Okay? As you know, when I create a list in Java, it's an empty list. And then I'm going to put things inside it. Okay? I create a class here that I call creature inner sense. Okay? Let me show you what is the creature inner sense. It's here in memory. Okay? So a creature inner sense is basically a position, which is a world point. A world point is three integers, okay? Two integers actually, x and y. So I have a world point here. It's a 2D point. A pitch is the angle of the creature around the world. So if I am, imagine that you're looking at the virtual world, okay? If I am at this position, I have a pitch of 0, okay? If I am here, I am with pi divided by 2. It is in radians, okay? If I am like this, I have pi, okay? Here and here. Okay, so 2 pi, I return to the same point. Okay, this is the pitch. Then I have a double, which is the few. So it's a number between, I don't remember if it's from 0 to 1 or if there is an amount. We need to check on that later. And there is also this polygon that is the field of view if I need it for something. In this case, you're not using it for anything. But it's just this frustrum I told you. It's a triangle in front of the creature where you are able to collect information. Okay? And this is all that we have here in the creature inner sense. Let's come back to our mind here. Okay? So I created this object inner sense, and then I create an inner sense memory object and provided this class as an internal part of the memory object. Okay? I created closest apple, which is null at the beginning. Okay, I insert this thing into the memory object of the closest apple memory object, and I create a known apples, which is a collection of array lists. And this is a trick in Java that we need to do. Because the array list in Java is not thread safe. Okay? It means that if there are multiple threads accessing it at the same time, it can generate a concurrent exception. Okay? So we use this trick of creating a collection synchronized list and pass an array list to it, and it's going to give me here a list that is thread safe. Okay? That's the only reason for this complicated thing here. Okay. Then we create the memory object for the known apples, so it's the memory object. And here we have a support class. What is this support class for? Well, all these things are happening in the background. It's difficult for us to see what is going on. Okay. So we created here a very simple mind view. What is a mind view? The mind view is something that is quite simple. Okay, I will show you here. The mind view is basically a text panel that is going to show you the contents of each of these memory objects, so you can monitor what is going on inside the architecture. Okay? Good. Let's come back to the agent mind. So I create here the mind view, and then I add all the memory objects that I want to inspect, okay? And you see that during the operation of the program, you are going to see this mind view showing what is in the memory objects at that point of time, okay? Well, then I created my codelets. So the first thing that I'm doing is create the vision codelet. Let's take a look on the vision codelet here. It's a sensor codelet, okay? And I have here the vision codelet. Well, that's a good time for you to take a look on the structure of a codelet, okay? The structure of a codelet is quite simple. We have basically the proc method. The proc method is this method that I told you that is called from time to time. Okay, so each 300 milliseconds, this method proc is called, okay, and released as soon as it finished. So what it's doing, it's using the creature class that we have created in the environment, okay, and doing an update state in this creature. This means you are contacting the environment, okay, and getting the situation of the environment and making it available in the creature proxy, okay? And then what I do is to call this method, get things in vision. This method is the magic one. It just gives me all the things that are in the frustrum of the creature, okay? And I store here as a list of things, okay? And what I do later, I take this list of things and set as the object of the vision MO memory object. Simple as this, okay? Nothing too much complicated, okay? So let's go back to the agent mind. So I created a vision object here, and then I need to indicate where this vision memory object, this vision codelet, puts its memory object. So I am saying, okay, the output is the vision MO, okay, just to connect things together. And then I do an insert codelet, and so this codelet is inserted in the code rack, okay? And now you do exactly the same thing with all the codelets. So I have an inner sense, I will create an inner sense, I will add the output of the inner sense, I will insert the codelet in the code rack. I will create a legs action codelet. It's good to take a view on the legs. Let's go to the motor codelet. Let's go to the legs action codelet, okay? So, as I told you, we are going to be using JSON in this small experiment. So you see that in the proc method, not in the proc method, I forget to tell you about the access memory objects. The access memory objects is other important method from the codelet class, because before starting calling procs, I need to have a reference for all the memory objects that I need, okay? So I need to do something like this. I need to call a get input, and I will use that string that I used in the creation of the memory object, okay? So I get this input with the name legs, okay, and start it on legs action, okay. Well, the first thing I do in the proc is to call the get information method. With the get information, I have access to that inner object here, okay, which I will do whatever I want to do, okay. And then what I do is that I will start, I will get this information. In our case, is a string, is a JSON string. and I'm going to make a parsing of this string, okay? So if I have this action, I will try to see which action, if it's for age, if it is go to, or if is something else, okay? So if it is a for age, what I'm going to do, I will ask the creature to rotate with a velocity of 2. So it stays rotating, okay? If it's a go to, I will use this move to command to move the commands in that direction. But there is an important thing for you to know, that the move to doesn't stop. It just moves in the direction of the you are doing. You need to call specifically it to stop if you want, okay? So if the command is neither a go to or a rotate, it is just send a move to 0, 0, 0 with velocity 0, so it just stops the creature. Okay, this is just for stopping the creature. Okay, and this is all this codelet do. Okay, let's come back to the mind. No, not to the mind here. Okay, no, it's not the mind. Oops. Let's go to the agent mind. Okay, so I created this codelet, I inserted an input and inserted into the list of codelets. Then I do exactly the same with the hands action codelet. The hands action codelet is exactly the same, but the difference is that here I have the pickup action. So the pickup will bring the apple, the jewel, or the nut inside the bag, okay? I can have an eat it. If it's an apple or a nut, I can eat the thing. I can bury, okay? And, oh, it's not here, but I could make an unbury if it's the case, okay? It's just examples here for you. If you can include other actions here if it's the case. You can unbury too, okay? Well, this is what the hands do. Okay, let's come back here to the where is it? Not here, not here, not here. Okay, agent mind. So I created the hands action coder. Then I will create the apple detector. Okay, the apple detector. It is here in the perception. Okay, the apple detector is going to have access to the vision memory object and to the known apples memory object. And what it's going to do is to go around all the things, okay? If it has this name p-food. P-food is the p-food are the perishable food, so apples basically, and non-perishable food, NP food, are the nuts. Okay, so if it's a nut or an apple, then I create this found. Okay, and and this is all I do, I believe. Is the apple detector? No, I need to do a set I somewhere. Let's see. Oh, here. I add. So I add the food here if it's the case. So if it's an apple or if it's a nut, I include it into the list of known apples. Okay. In this case, we are going to have only apples. That's the reason that I just put them together. Okay. Okay, let's come back. Then I create the inputs and outputs of the apple detector. I do the same with the closest apple detector. I'm not going into the closest apple detector right now. You can see it later in your code, okay? I do the same for the go to closest apple, okay? To the eat apple, to the forage, okay? And then in this case, I set all of these codets to run by 200 milliseconds, okay? I could use a different number. It will depend on your computer, okay? This is a number that is nice. Well, after I do everything, I do the magic start, and the show starts, okay? The codelet starts to run, and all the things start to happen together, and it works, okay? So, basically, this is the use of CST for creating the creature, okay? So, let's go now to the website. Okay. Well, it's a little bit bigger here. Let me see if I can. I think it's a little bit better like this. Okay. So, what is now the activities for you? The idea is that first you need to download the source code of the demo CST, okay? We need to download the WS3D source code, okay? And then I will ask you to run the WS3D. I will try to pass through you to help you in doing that, so if you have any problem. And now you ask you to explore a little bit of the word server to see what is possible to be done. And after you start the word server, then you can start the demo CST. And you see that they will plug in the word server, and it is going to run. Unfortunately, the display here don't allow me to do that here for you because the word server is going down. But hopefully you can do that in your computer, okay? These are the kinds of things that we can do. We can create blocks here, and we can put things in the environment, okay? Then we need to understand the proxy. So we need to take a look on the code of the creature class and the world class. These are the two classes that you need just to know the commands that you can use. But we are always using it on the demo, okay? And then there comes the challenge for you, okay? So the first thing is to understand the code and see it working. The second thing is the challenge. And here I need to give you some more information, okay? Well, what is the challenge for you? The challenge is based on these demo code that I am sending to you that only picks apples, okay? Now I want you to pick crystals and food meeting this specification. If the energy is higher than 40%, the creature should collect food, okay? If there are apples and nuts in the front of the creature, probably you can eat it just for it not to collide, because it's going to collide with apples and nuts if you don't pick them, okay? Then the creature should search for the crystals necessary to complete their leaflets and trade these crystals for points, okay? If the energy level decreases below 40%, the creature should look for the closest food and just pick crystals in the middle of the way if they are obstructing the way, okay? Uh, it's not so difficult to do that. But there is a problem, and I will tell you why. And this is the reason that I need to come back now to my original slides. Okay. Well, why we need the container? You remember that I told you that the container is necessary in this case, okay? Let's come back to the architecture for you to understand why the container is needed, okay? Well, in this particular configuration, we have a very peculiar situation. What is this peculiar situation? Well, if there is a closest apple, the go to closest apple sends a command to the legs to go to this apple, okay? And the forage does nothing. It remains quiet. So the forage is a little bit intelligent in this sense. So if there is a closest apple, the forage doesn't do anything, okay? In fact, it doesn't use the closest apple, it uses the known apple. If the known apples are greater than 0, it doesn't send a command. If it's higher than 0, then it tells, if it's equal to 0, then it tells the legs to forage, okay? And then you can see the nature of the problem. What is going to happen if I have two codelets sending commands to the same memory object? What do you think that is going to happen? Exactly, exactly. One will be substituting the other, okay? And the system is going to do nothing, okay? In this particular configuration, it works like a charm. Why? Because they are mutual exclusive situations, okay? Either you have apple or you don't. If you have apple, go to the closest apple. If you don't, you forage, okay? Quite easy. But now, with your challenge, it is not possible anymore to use this like this. Because you have, for example, many Jews and apples. So at least you have to decide if you go to pick a Jew or if you go to pick an apple. And to keep with this, it's not good. So we need to provide a solution for you. And this solution is the use of a container, okay? Let's understand what the container does, okay? The container is just like a memory object, exactly equal to a memory object, in theory. Internally, the container is doing some work. What is the work? This is the internal part of the container, okay? In this example, for example, we are receiving 3 different orders at the same time. It doesn't need to be exactly at the same time. There could be a small difference. But the question is, we have 3 different orders that are reaching this container, okay? So what the container is doing? The container is not doing anything too much complicated. It's quite simple, actually. It is going to receive each of these commands. You remember at the beginning when I told you that there is here in the memory object extra information, and I told you that one of these information is the eval. The eval is the evaluation. It's a number between 0 and 1, for example. It can be any number, in fact. The idea is that each of these commands, they, together with the commands, they will have a different evaluation, okay? So imagine that you have 2. Forget the third one. I have 2, okay? So if the energy level is higher than 40%, the dual command will have an evaluation bigger than the go to Apple command. Okay? If the energy level is higher, then it's the opposite. Okay? So what we need to do? We need to use this extra field of the memory object, in fact, of the memory container, the memory interface. Okay? All the memory interface has this eval. Because internally here in the memory container, there will be a selection codelet that will be looking at all the different orders and picking the one which has the biggest evaluation value. Okay, simple, nothing too much complicated. And then when you ask for the content of what here inside of the memory, it is going to return the memory object that is the winner of this competition. Okay? So this is the magical trick that is done by the container. Okay? And you will need to do that, because otherwise it is not going to work. Okay? There is a tricky way of doing that, and I will show you how to do that, because otherwise you have some difficulty in doing that. Okay? Do you understood the idea of the container? Is it okay, or you need more information about that? Please. No, you see, when I'm talking about a container, I am using the same interface. I have the get I, which gives me the info, and I have the set I, which stores the info. The difference is that in the memory object, the info is exactly the same, okay? But in the container, the info is not the same. So the codelet here is going to do a set I of an object inside the container. This one is going to do a set I inside the container. This one is going to do a set I inside the container. Inside the container, they are different. But if you ask a get I from the container, it is going to select and send the winner. Okay, that's the idea. So the interface is exactly the same. So the memory container works just like the memory object, but the difference is that when you do a set I, you don't overwrite what the others are doing. All of them are considered together. Okay? It's okay? Yeah? There was another question somewhere here. No? Okay? Okay, let's try to understand how we need to do that. Because if you don't understand that, probably you have problems in trying to make it work. Okay? So, the first thing is that, well, probably I will need to create here I'm not going to create all of them here because I want you to think a little bit about that. But what I'm going to do is to just make changes here in the agent mind. Okay? So at the beginning, the legs MO, they are a memory object. Okay? So what I need to do right now, I need to change that to a memory container. Okay? So okay, I changed it to the memory container. The memory container is a little bit different from the the memory object because I cannot make an initialization of it directly. Okay, I need to do that myself. Okay, and then probably I need to make a legsmo dot set I of string, empty string here. Okay, so I have done this here, and I'm done his here. Handsmo dot set I, and I have here. Okay, perfect. Well, now in this situation, the legsmo is not a memory object anymore. Now it's a memory container. So, for example, I can have here I will copy that, and I will make an effective copy. And instead of go to closest apple, I, for example, will go to the closest jewel. Okay? Okay, created a go to closest jewel. Okay? So both the go to closest apple and the go to closest jewel will be sending to the same memory object that is now a memory container. Okay? So I need to make a difference between them. Otherwise, they are not going to work. Let's go to the go to closest jewel. Okay? In the go to closest jewel, I need to prepare it for being using. So here you can see that now the legs are not a memory object anymore. So I know that now the legs are the memory container. Okay? They are memory container. And I need to have a trick here. Okay? I need to have a trick here. The trick is the following. Here. You see, at this point, I am doing a set I to set an object in the legs. Okay? But now, because it's a container, I cannot just set it in anywhere. Okay? I need to use one of these internal slots of the container. Okay? So I made a trick here for you. I hope that you can follow me. What I'm going to do is that, well, first I will create here a private int counter equal -1. Okay? You are going to understand what is happening here. Here, instead of just calling the set I will need the trick. If counter greater than 0, then I will do a legsmo dot set I. Let's make a copy here. Just like here. Okay. But then I will not do like this. Okay? I will need to pass here counter, and I need to do a double eval equal 0.8, for example. Let's see. not? Well, let's see. And then else I do a counter equal lexmo. That's it. Why it's not working here? Lexmo set e. Lexmo is a memory container. Yeah. Oh, I need to change it here. Okay, that's true. The lexmo cannot be anymore a memory. It needs to be a memory container. That's what was missing. Okay. So, what I have did there, see if you can follow me, okay? In this case, you can see that at the beginning, the value of counter is -1, okay? The counter is -1 when I start. And then, when at the first time I pass in this part of the code, the counter will not be greater than 0. Okay, greater or equal. Yeah. So I will go to the else. And then I do the normal thing, that is to start a set I, just like as I was doing in the old case. Okay? And then I initialize the counter. So depending on the first codelet, in this case I'm doing this for the closest apple, okay? I don't know if it's going to be the closest apple or the closest jewel. One of them is going to be called first. The first one will return here a value of 0. The second will return a value of 1, 2 or 3 or 4. So it depends on how many of them are writing in the container, okay? And then after I receive that, I need, every time I call the set I need to pass this counter again to access the same memory object inside the container. Okay? It's a trick. I hope you can understand the logic of it. Okay? But this is what you need to do. Because if you just call set I, the container is going to just have a lot of objects, and it is going to explode, and the things are not going to work. Okay, so this is what you need to do. Okay? Well, and now the time comes. Now it's with you. Okay? So I expect you to try to run the word server. I will pass through all the chairs, okay? Just to see how are you doing with that. And I will try to help you in trying to attach this program, okay? You need to think, well, what you should do. You should do something like I suggested, okay? I have a go to closest apple. I will have probably a go to closest jewel. I need to create some codelets, and I need to put these containers to work. And then I need to have a better logic for creating the value of this eval. Okay, I need, for example, to use this sys object to see the energy level. Okay, so probably what I need to do is do something like this. Okay, so if sys dot foo is less than 0.4, then eval equals this is the apple, so this is equal to 1. Okay, oops, else eval equals to 0. Okay, and then I will send the right eval here to the system. Okay, and on the closest jewel, you are going to do the opposite. Okay, and so they are going to go to the right in the right situation they are going to work. Okay? So let's start working, and I will try to pass through you and try to help you with some difficulties that you are having, and hopefully you are able to run everything. Okay? We have not too much, 1 hour for doing that, so let's try to see if it's possible to run like that. Okay? Pardon? I will go to you to help you do that. Do you want to take this off, or you're keep okay? Have you downloaded the code? You need to run the word server here. So click the right button and go run. Yeah, like this. So you have the server running here. Okay. Then if you run the demo, okay, you run and you wait a little bit, and it's going to create everything for you. Is it working or? Or there was, oh, it failed in something. Oh, please do a git download it again. There was a small typo yesterday at night, and probably you downloaded it before I made the correction, so we need to download it again. No, git remote pull from upstream. Yeah. Just check if it's worked. Now compile it again. Just check here if it's compiled. I think here. Finished, so you can run it now. Yeah, it's working right now. Okay, so just wait a little bit, and it's going to start. Yeah, you see, it's foraging now. It's going to the apples. Yeah. Okay. And this is the view, the mind view. So this is what is happening inside the mind. What is in each of these objects that we are running. Okay. People, just one remark. I just forgot. I remember that right now. Yesterday night, I made a small change in the code, and I broke it, and then I constructed again. So for some reason you are not being able to run the demo CST, please make a new download of the Git code of the demo CST, and it will be fixed. Okay. Otherwise, you're going to have some difficulties depending on the time where you downloaded it. If you downloaded too early, probably you are with this problem.
Sorry.
Oh, you're working. Okay.
I'm not even able to run the world.
Not? Do you have your machine with you? Yeah, I can help you. Could you be able to run it? No? Oh, probably you have it failed. So you need to download the demo CST again, and then compile it again. Just that. Okay. What is the?
A couple of ones. Right, just make run this.
So okay, the problem is that probably you are not using Java 8. You are using a higher version of Java. And the word server doesn't work with greater. Can you open a terminal, and we can check. the command. Then call Java minus version, space minus version. Yeah. Yeah, it's Java 10. You need to switch to Java 8. That's the reason it's not going to work. It working now? No.
Because if I will
Yes. It takes some time because it needs to download all the dependencies, so you need to wait a little bit. Do you have internet access here? Okay, so wait a little bit. It's still trying to download because Gradle looks for all the dependencies and it starts downloading all the dependencies in an isolated way, and it takes some time for that.
in fact, not the objects like person down. It was very quickly.
Strange.
Yeah.
Well, try to do that inside the. Yeah, it's here. Huh? Try to. Well, it's already cloned. Okay, compile it now. Here, click on the demo CST, the right button, and then run. Yeah. So try to compile it first instead of just running it. Now here, right button, and then there is task, run Gradle, tasks. Oh, what is strange. Call a build here. Build. Just double click it. Let's see what is happening here in the build.
Yeah.
Successful? Okay, now try a run. Over there? No. Oh. Let's see what's happening. Finish with no zero. Oh, you have a debugger here. The build was successful. Why is it complaining? Oh, you already run the word server? You need to run the word server first. Run. Oh, you are having the same problem. You are using the Java, which is not Java 8. You need to switch to Java 8.
Java 8.
Yeah, because it's not compatible with Java greater than 8.
Okay.
That's the reason it's not working. So when you finishing the switch, you call me back. And you're?
What should I do after that?
Okay. Now you need to do to the demo CST and start the demo CST. You don't need it. It's just for you to learn about the options. Yeah. Now you can switch to the. You should probably see it. Oh yeah, it's already working. So you can see that it's already.
But where is my roles?
Oh no, it created a new environment. You need to construct your environment programmatically. You need to give comments for it to construct things. So this is why you need that proxy classes. You need to know how do you create those barriers. Okay. But in this challenge, you don't need the blocks. You just need to create jewels and apples and let the agent to do exactly this. But now understanding how to choose between jewels and and apples. Okay? Do you have a clue on how to proceed, or you are still stuck?
I don't know Java language,
Oh,
and it's hard for me.
yeah, probably. Maybe you can join some of your colleagues and try to follow with them.
I think that I can end this project in my mission.
Okay, it's up to you. Because we really need to understand a little bit of Java for doing things. Because what you need to do is to create other codelets. So you need to create codelets now to detect known duos and to detect the closest duo, okay? And then they need to compete between duos and apples depending on the circumstance. So it's not so difficult, but you need some Java understanding for doing this, okay? So what about you? No. Oh, but you are having problem? No, so or in other things.
I'm a paper red now.
Okay, okay, no problem. Oops. And what about you?
Static because I have low
Oh, you have block. Maybe there are some plugs for you to connect. I believe that there are some electricity in some places here. We need to look for. Oh, here. If you move to here, you can use it. There are many here. So what about you here? Could you run it? Yeah. Okay, so it's working right now. You just need to make the changes. Okay. And these people here. You have problems? What was the problem? It the word server was running, or what was the problem?
No, we actually didn't get to the word server. We were trying to launch the client stuff like that, and we actually technically did it, but they didn't.
Okay.
And
So you're following him.
well, like they pretty much did that.
You run the word server?
I have yes, I understand, but I have problem with demo CST and CST because
Oh, forget about demo CST. It's a bug on the NetBeans. Go to the demo CST. Demo CST should work.
DMST says that bird no bird
BR.
BR Unicamp CST not found, and
Oh.
I don't know how.
No,
to
try to build it again.
Okay.
The demo CST. Yeah, let's see if it builds properly. Because the problem is that they first need to download all the dependencies. This is Gradle. Gradle do this for you in the background. But sometimes, depending on the connection, they fail in the between, and you need to do it again. So let's see if it's the case. Take a look here, build demo CST, successful. So now it is perfect, okay? It should work. You can just run the demo CST, and it's going to just clean everything you've done already in the. You can do that from NetBeans, yeah. No, don't shut down. You need it open. The best way of doing this is using the right button and looking for run, and it should work, yeah. And then you can run the demo CST. Then you switch to the other view for you to see the word server. Yeah. So it created some apples, and then it's creating things, and then it's a little bit slow, but yeah, it's doing its. And here is what is in the memory objects. You can see what is going on. Okay. So now you need to think about what you need to do to extend the architecture for it to collect jewels. Okay. Basically, the idea is, okay, I have these known apples and closest apple. I need to create two new memory objects, the known jewels and the closest jewel. Okay, and then I need to create a new codelet called go to jewel. Okay, and then we need to change also we need to create a get jewel, which is somewhat similar to the eat apple. Okay, the common is not going to be exactly the same, but it is going to be very close. And this should be enough. A smaller one or a bigger one? If you do like you can see. Okay, so it's. And if you use your arrows, you also can do like this. Okay, so it's. And if for some reason you get stuck, you just press R and it comes back to the original thing. Okay.
And I need to program
Yes, you don't need to put another creature. You are going to use the same creature, but you need to extend its behavior. Okay. So yeah, go to here. You see, here we have this diagram. Here we have these two. You need to include two others, okay? The known jewels and closest jewel. And then you need to create perceptual codes for them in order to feed them, okay? And on the other side here, you need to create some behavioral codelets to do the behavior of moving to the jewel and getting the jewel from the environment, okay? Yeah, it's not, by this time, it's not intelligent enough to survive to that, you see. There are ways of creating codelets and creating behavior to try to avoid the collision, but it needs some intelligence for doing that, okay. As I told you, this is a, basically because it was in doubt which one is the closest one, because as soon as they move, the other one becomes closer, and so it's. So this is one of the most basic cognitive architectures. This is a subsumption architecture. And of course that it has its problems, and there are many ways to avoid this problem. You can double click there and okay. So let's start thinking, and then I will try helping you in trying to solve that. Okay. I know that. So are you progressing here? No?
we're trying to migrate from OpenGDK8 to OpenGDK11.
Oh, you should do the contrary. You should go to JDK 8, because JDK 11 is not going to work. Click on OpenGDK 8. Yeah. Yeah. That's it. You know, this is one of the bad things of Oracle. They just eliminated some classes from the OpenGDK 8, and so these classes doesn't exist anymore in JDK 11. That's the reason that the code doesn't work. They broke a lot of people with that, so. People is complaining a lot. Could you make the switch here?
Because stores exist 8, 10, et other, but no 9.
8.
No, not 8.
You don't have 8? But you can download it. There is a link I have sent to you where you can download it. Go to the website that over there. It was open there, yeah, over there. So if you go, there is OpenGDK. Yeah.
But it is 8.
Yes, it's OpenGDK 8.
It is enough. 8, yes, but 8 is it enough because Java environment requirement to NetBeans.
No.
No?
NetBeans doesn't require. NetBeans is compatible with, but it works with JDK8 too. But probably you need to close NetBeans because it's actually running the other JDK. So close it, install the new JDK, and then you can open it again.
JDK
8.
7 inspector. NetBeans.
Sorry.
Yeah.
Will you speak about everyone?
Probably not anymore. So just to
you
close.
will talk to individual from now on.
I will follow everybody and try to help them, and at the end I just made a final conclusion. And do you want me to simulate a final conclusion there so you can tape it?
Well, I guess it's not perfect. So
Okay. Yeah.